Hello friends, so today we are going to discuss thermal power plant, which is also called as a steam power plant. But before moving to the interesting facts regarding thermal power plant, in today's video we have introduced one more element, which is a quick question answer session. In this element, we have asked few questions to our previous engineering students as well as to my engineering friends. So let's see how they have responded.
Station in which heat is used to generate electrical power.
It is used to convert heat energy to electric power.
It generates electricity by heating water.
It generates electricity with the help of coal.
No.
Yes, definitely. I have visited Vidyanchal thermal power plant in Madhya Pradesh, and which is owned by the NTPC, and it's one of the largest thermal plant in our India. With the combustion of coal, we can generate the electricity.
It generates electricity by heating water with the help of fossil fuel.
The steam is used to rotate the turbine so as to generate electrical power.
The heat energy is used to rotate the turbine. Then it is converted to mechanical energy, and then the mechanical energy is converted to electrical energy. Hydroelectric power plant.
It will be wind power plant or solar power plant.
Nuclear power plant.
Well, the solar and wind, and of course the hydro.
Causes a lot of pollution.
A lot of environmental degradation.
Pollution.
They also cause very harm to the environment, such as air pollution and water pollution. And there is also limited supply of fossil fuels. So I think we should move on to renewable sources of energy.
We will see answer of all these questions in this video. But before moving to the detailed answers of all these questions, let's see few interesting facts related to the thermal power station. In 1882, the world's first coal-fired power station, that is Edison Electric Light Station, was built in London. It was a project of Thomas Edison which was organized by Edward Johnson. Sir Charles Pearson, who built the first steam turbine generator with a thermal efficiency of just 1.6% in 1884. Considering world's biggest thermal power plant, Taichung Power Station, which is situated in Taiwan, is coal-fired power station, which has a capacity of 5,788 megawatt generation. Considering India, Hussain Sagar Thermal Power Station is India's first thermal power station, which is situated in Hyderabad and opened in 1920 by erstwhile 7th Nizam of Hyderabad. In current scenario, Vidyanchal Thermal Power Station is India's biggest thermal power plant, which is situated in Madhya Pradesh and having a capacity of 4760, that is 4760 megawatts generation. Considering total energy generation in India, 65% of the total energy generated is from thermal power station. Out of that, 85% thermal generation is coal-based. These are few interesting facts about thermal power station. In the next part of the video, we are going to see detailed working of thermal power plant with all its elements, and where you will get the answers of all the questions previously asked. But before that, you solve this quiz. In this part of the video, we are going to discuss a detailed working of thermal power plant. The line diagram that we have used over here looks very difficult and confusing at first sight, but it is very easy to understand if you go one by one all the elements. So now just focus on the diagram, understand working of each and every element in order to understand the working of thermal power plant. If you go through this figure, the first and important part come across you is a boiler. There are two types of boiler. First one is a water tube boiler in which water flows through the tubes and fire surrounds the tube. The second type of the boiler is a fire tube boiler, in which fire flows through the tubes and water surrounds the tubes. In our case, for the explanation, we have taken water tube boiler. But what is boiler? Boiler is a closed vessel in which water or other liquid is heated in order to generate steam by the direct application of energy from the combustion of fuels in case of thermal power plant. If you look at the figure carefully, you can see the heat is supplied with the help of flames. These flames are coming out of the furnace, that is combustion chamber, and this combustion chamber is connected with the pulverizer. This element is called as a pulverizer. So what exactly is a pulverizer and how it works? So pulverizers, or you can say the coal pulverizer, are used to pulverize pieces of coal into fine particles that is approximately equal to 100 micrometer before placing into a combustion chamber, that is furnace of a boiler, to ensure efficient combustion. Pulverizers have three functions. First one is a pulverization, second one is a drying, and third one is a classification. Out of these three functions, the classification function plays the important role of ensuring that only fine particles of the pulverized coal are sent to the furnace, that is combustion chamber of the boiler. Because finer the grinding of coal, the more efficient its combustion. One more element you can see here, that is a hopper. It is a coal hopper through which the coal is fed into the pulverizer. Now the next element is a superheater. One can see here the steam is coming from the boiler and allowed to pass through the superheater. But same time, through this animation, you can see here the superheater is placed in the path of the flue gases. So superheater takes the heat from the flue gases and supply it to the steam in order to convert saturated or wet steam into the superheated steam. Because superheated steam or dry steam contains more thermal energy, hence it increases the overall efficiency of the thermal power plant. Now this supersaturated high pressure steam is passed over the turbine blades. Turbine blades are mounted on the turbine shaft. Hence it rotates the turbine shaft, and finally it produces mechanical work. Now you can see here the turbine shaft is mechanically coupled with the generator shaft. Hence the mechanical work is converted into electrical energy with the help of generator. Now the next element is a condenser. The steam from the steam turbine is thrown out to the condenser, where the steam is condensed by rejecting heat to circulated cooling water. From the animation, you can see here the cooling water from cooling tower is supplied to the condenser and absorbs heat from the exhaust steam of the steam turbine. The resultant heated water from the condenser is given at the top of the cooling tower. This heated water gets cooled by the cool air passed from the bottom of cooling tower. The heated air is thrown out to the surrounding from the top of the cooling tower. Now the next very important element is an economizer. The condensed steam from the condenser is called as a condensate, which is given to the water reservoir. Now this condensate from the water reservoir with makeup water is fed back with the help of a feed pump at boiler pressure to the economizer. It is not directly supplied to the boiler, because in this figure you can see with the help of animation the economizer is placed in the path of the flue gases. Hence, economizer takes heat from the flue gases in order to preheat the feeding water, that is condensate plus makeup water mixture. So therefore, when economizer supplies this feed water to the boiler, it is already heated up to a certain temperature, and hence in the boiler it requires less heat to convert it into the steam, and therefore it requires less fuel and hence improves the overall efficiency of the thermal power plant. Now next very important element is air preheater. As you can see in the figure, the air preheater is placed in the path of the flue gases. We know that for the combustion process we need air from the surrounding. Instead of directly supplying air, we have passed this surrounding air through the air preheater. The main function of the air preheater is to exchange the heat of the flue gases with the air in order to preheat the air before supplying it to the furnace for the combustion purpose. Therefore, when air preheater supplies the surrounding air, it is already heated to a certain temperature, that is above atmospheric temperature. Hence, it requires a less fuel for the combustion process, and therefore it improves the overall thermal efficiency of the thermal power plant. Now the next element is a dust collector, which is also called as a precipitator. It is a filtration device that removes fine particles like dust and smoke from the flowing gas using the force of an induced electrostatic charge, minimally impeding the flow of gases through the unit. The last part of the thermal power plant is a chimney. It is an architectural ventilation structure made of masonry, clay or metal that isolates hot toxic exhaust gases or smoke produced by a boiler from human living areas. So friends, this is all about working of thermal power plant. It is very easy to remember the whole working. You first start with the four major elements, that is a boiler, then the turbine, then the condenser, and finally the water reservoir. Once you are done with the explaining these four major elements, then proceed with the accessories which improves the overall efficiency of the thermal power plant, like superheater, then economizer and air preheater. In the end, you explain the remaining elements like a cooling tower, dust collector, and finally the chimney. So this is how you can easily remember the working of thermal power plant. Now in the next part of the video, we are going to discuss how energy conversion takes place in the thermal power plant. But before that, you solve this quiz. In this part of the video, we are going to understand the energy conversion process in thermal power plant. This is a schematic diagram that we have already learned in the previous part of the video. So now we will start from one point to another point and we'll see how energy conversion takes place. The first form of an energy is a chemical energy, which is available because of storage of the coal. This chemical energy is converted into a heat energy by coal combustion in the furnace. After heat energy, the next form of energy is a kinetic energy, which is obtained by conversion of water into the steam in boiler. Water gets heated in the boiler and converted into the steam, and steam starts flowing into these tubes. And this flow gives you a kinetic energy. Now this kinetic energy is converted into mechanical energy as steam passes over this turbine blade and turbine starts rotating. Hence, mechanical energy is nothing but rotation of turbine shaft. Now, this turbine shaft is mechanically coupled with the generator. Hence, this mechanical energy is converted into the electrical energy. This is how the energy conversion takes place in thermal power plant. In the next part, we will see advantages and disadvantages of the thermal power plant. In the last part of the video, we are going to see how to write an answer if question is asked on the thermal power plant. First, you have to explain the basic principle of steam power plant with the help of energy conversion that we have already learned in the previous part. Then you have to draw a layout of thermal power plant mentioning all the essential elements of the thermal or steam power plant. Now explain working of thermal power plant mentioning all the essential elements like boiler, air preheater, superheater, economizer, and then steam turbine, generator, condenser, boiler, feed pump. Now the last part is advantages and disadvantages. In this way you can finish the answer of question based on thermal power plant.